Уважаемые товарищи, городской совет народных депутатов сообщает, что в связи с аварией на Чернобыльской атомной электростанции в городе Припяти складывается неблагоприятная радиационная обстановка.
In this project, we will show a graphic summary along with an explanation of the graph that represents exponential growth, as well as a summary of the disaster and two other real events where exponential growth has occurred. This is a graphic summary that explains the basic graph that represents exponential function. When a is greater than 1, the graphs are represented by the following formula, in which y is the amount of neutrons released during nuclear fission and x is the amount of chain reactions. This graph shows the exponential growth of released neutrons. Asymptote is y equals 0 because fission can't be negative. The domain includes all the real numbers. The range is over 0, there is no vertical asymptote, and it's always increasing their value. In graphs where a is greater than 1, the reference point is located in 0, 1. When a is greater than 0 but less than 1, the graphs are represented by the following formula. There is no vertical asymptote and the values are always decreasing. The asymptote is also found in y equals 0. In this type of graphs, the domain also includes all the real numbers and the range is over 0. The reference point is located in 0, 1. On the morning of April 26, 1986 at 1:23 a.m., the world's worst ever nuclear accident took place in the Chernobyl nuclear plant near the city of Pripyat, Ukraine. An explosion of fire from the plant's reactor number 4 brought death and disease due to the radioactivity that was sent into the atmosphere. The accident also brought into question the idea of nuclear power. The trauma within the Soviet Union was so severe that many people see it as the first step of the communist regime's breakup. That night, the reactor was in the hands of 3 men: Leonid Tuptanov, senior control engineer, Alexander Akimov, shift supervisor and captain of the ship. However, Akimov was outranked that night by Deputy Chief Engineer Anatoly Dyatlov. The accident happened during a safety test demanded by Russia's energy authorities to see how the plant would operate if it lost power. The reason being that a few years before, the Israeli Air Force bombed an Iraqi nuclear reactor built by them. Since then, Soviet scientists made the tests a requisite. However, Deputy Chief Engineer Anatoly Dyatlov deliberately ignored the advice on how the tests should be done. Arguments brewed between the 2 senior engineers and Dyatlov on the level of power in which it's safe to begin the tests. Several mistakes from plant operators ensued. The guidelines, which clearly stated that the reactor's power should be between 700 and 1,000 megawatts to begin the tests, were ignored by Dyatlov, who wanted to begin the test at 200 megawatts in order to preserve the cooling water that stops the reactor from overheating. Nevertheless, they proceeded with the tests. However, there was a potentially fatal flaw in the reactor's design which the engineers were unaware of: the floor, which was highly unstable when running at low power. Letting the power down led to it dropping too far. 22 minutes before 1, the reactor came to a complete halt. A nuclear reactor can be compared to a giant steam engine. The uranium-filled rods inside it react to produce large amounts of heat, which converts water into steam. This makes the turbines generate electricity. The control rods are inserted in between the uranium for better control and to slow the reaction. They are also essential for pumping cooling water around the core in order to prevent it from overheating. When the test began, the majority of the control rods were removed. This caused a loss in control over the flow of temperature. As a result, extreme heat began to melt the core. When the operators began to reinsert the rods to slow the reaction, a design flaw in the rods caused it to jam. The steam, which was the most likely factor to cause the reactor's explosion, caused a second explosion just a few seconds later. The radioactive release from the explosion has been estimated to be 400 times the size of the atomic bomb dropped in Hiroshima. Debris from the explosion caused another series of fires around the plant, which in turn released radioactive smoke. Nuclear energy from the explosion hasn't been able to be contained due to fission reaction. This reaction starts with one atom of uranium. One accelerated neutron is fired at the atom in order for the reaction to start. Once the neutron comes in contact with the atom, it is split and creates two different elements, releasing energy and 3 neutrons. These neutrons will then split into 3 more atoms. For every atom split, 3 more neutrons are released along with energy, resulting in exponential growth and mass destruction. The total death toll from cancer from the accident is estimated to be 4,000 for people exposed to high doses of radiation, and another 5,000 deaths of those who had less radiation exposure. According to the International Atomic Energy Agency, the United Nations, and the World Health Organization, a lack of iodine in the diets of children living in the contaminated region has made them more susceptible to thyroid cancer and iodine deficiency disorders. Congenital birth defects have increased by 250% since the accident. The ones most affected by the events from that night up until this day are the children generation. There are many real-life situations where exponential growth can be seen. An example is the increase in the number of bacteria in a population. This growth occurs in a geometric or exponential manner. With each division cycle, one cell divides into 2 cells. Those 2 cells divide into 2 more others, and so on. The time it takes for this to occur can be calculated by the following formula, in which capital B is the number of bacteria present at the start of the observation, lowercase b is the number present after the time period t, and n is the number of generations. This is only valid during the period when the population is increasing exponentially. It is called the log phase of growth. This is why graphs show that growth of bacteria are plotted as the logarithm of the number of cells. An example of exponential decay is in the inverse square law. The volume of sound decreases in a 1/d² relationship. If, for example, you move 4 times further away, the sound level will only be 1/16 of what it was before. The same thing happens with the light intensity from a projector, who also follows the inverse square of 1/d² relationship as shown in the image.
Exponential growth refers to an increase in growth of a proportion at a rapid state. The slope is increasing constantly, as shown on the graph. It represents a constant rate of growth applied to a continuously growing base over a certain period of time. Exponential growth has 2 important characteristics to consider. The first is its power, as exponential growth can occur very rapidly. The second characteristic is its insidiousness. On the other hand, exponential decay refers to a process or operation of reducing a percentage repeatedly over a period of time. When a population or group is declining, the decreasing amount is proportional to the size of the population or group. The total value decreases, but the proportion that leaves remains constant over time. When using nuclear energy, it implies that you have a stacked amount of security measures in the maintaining of the nuclear reactor, since with any minimum error you can create a great destructive consequence for all the living persons and things that are near them. We consider nuclear energy to be the cleanest of all energy sources and technologies out there, since they are the ones that don't emit any type of carbon dioxide emissions to the environment. Nuclear energy also uses a very small amount of fuel. A nuclear energy plant exists in our country. However, we weren't aware of its existence in Mexico. But with the research made in this project, we learned about its existence in Alto Lucero, Veracruz. The nuclear plant's name is Laguna Verde, and we believe that the plant is safe and it has been operating for more than 20 years and it's located in an isolated area. Also, because there has never been recorded an accident from this plant, we consider the fact of having a nuclear plant in our country as a benefit.
The 1986 nuclear disaster could have been prevented if the people that were managing the plant were more experienced and had created a nuclear plant that was designed properly. If the process of operating the nuclear plant would have been done automatically by using computers instead of workers who did it manually and did not have enough experience, this disaster would not have occurred. The radioactive pollution probably did not reach Mexico because the damaging substances were spread by the wind, but Mexico is located at a long distance from where the accident occurred. Some environmental consequences of other nuclear disasters and nuclear weapons in the world are the contamination of several territories that are no longer available for population to crop or to be there thanks to still having a radiation radius around them. Solid waste also has to be disposed, so there has been created specific land spaces. The collection of solid wastes that are produced during the nuclear disasters. The worst consequences are the emissions of the radioactive gases into the environment, affecting humans, plants, and animals. These consequences are of great damage to the world and should be prevented at all costs. I think all nuclear power plants should follow all safety standards and have extremely qualified employees. The plants should also be as far away from society as possible, so that in case of an accident, less people would be hurt or damaged. We liked having to deal with a real-life problem and its mathematical implication, because this way we can see how the curves will help us during our lives, even if we don't study something that has to do with math. Yes, it was difficult to understand the issue, but as a team we worked together and figured it out. I think it is good to work with teams from different campuses so we can compare our knowledge from classes of different teachers and see whether we share the same thoughts and ways to solve problems.